So the random variable x z is defined as you take the first observation minus the second observation, but you don't mod it. Okay. The second one you mod it lah. So what I'm saying is essentially the first one is, can you imagine that now that if you take x1 minus x2 without modulus it, right? Meaning all these here would be negative. Get it? All these will be negative. This side here. Because all these are x1 smaller than x2. Ma. So this side here, all this portion here will be negative number instead of positive one. That's about it. So means for your z distribution, right, you have from -5 to 5. Okay, just that the chances are being split. So this one will half. So I can quickly draw this out. For z, right, distribution, right? If you really understand what's going on, this will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. So this case here, this is z, this is p, z equals to z. So this is -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. By understanding my z, I know that the chances here will be 6/36. Okay. For the 1, it will be 5 instead of 10 because it will be divided over here, half of it. Then that will be 4, 3, 2, 1. 4, 3, 2, 1. Is that okay? So just by looking at the equation, I'll get to understand what's going on. But you don't really need to write down the diagram down. Okay, you can just I'm just speaking out loud what I'm thinking and how I'm approaching the question. Very quickly can tell is like that. Okay, is that all right? So without the mod, you will stretch all the way -5, and you just split you split half of the positive one over the negative side. It's just by looking at this diagram here. Okay, now, so for the first part, stay with a reason whether or not EZ squared equals to EY squared. So, is it the same? So Z squared will be x1 minus x1 minus x2 square, right? Right. And also, you know that this will give you x1 minus modulus x1 minus x2 square. Is that okay? It's just basically x squared equals to mod x squared. When this is square, you can just mod it. So in other words, this is just y square. So z square equals to y square. Hence, expectation of z square equals to expectation of y square. Okay, this one is very straightforward because if you were to square it, if you were to square this, right, this and this, right, they will have the same probability distribution table, the same, exactly the same. Okay, so this is the first one. Actually, you can just write it like that. So it's the first part. It's just it's just algebra. And part 2, variance z and variance y, is it the same? No, right? Do you see the distribution table is different? Okay, so the spread will be different. So why is the same one? No, you don't times twice the probability. It'll be the same. You see, it'll be the same. So let me show you how it becomes. Z squared, this will be 25, right? This is also 25, right? This is 16, this is 9, this is 2, this is 101, 2, 9, 16, right? It will be the same. So Z squared would actually be 0, 1, 2, 9, 16, and 25. And essentially the probability of Z squared equals to Z squared. 0 will be 6/36. 1 will be this plus this one. Then this will be this plus this one. This, then it will be the same as the y square. Okay, is that okay? So it's the same because when you square it, you need to merge the probability up. Okay. If you want to know what's going on back end, this is Z square. Part 2. Part 2. But square never merge. But y square, oh, because you square it is the same. If you take y square, this is 0, this is 1, this is 4, this is 9, 16, and 25. Is the reason why you merge is because these are same data point, 25. If it y square only merge because you don't have any same one. If you have same one, then you need to merge. But for z square, you need to merge. Yeah. Okay. That's it. Part 2. Part 2 will be okay, so for part 2, variance z and variance y. Okay. Variance z and variance y, you will get different, right? Is variance z equals to variance y? How do you show? Okay, here. So should be lesser p than z squared, I thought. Hey, you don't square the probability. Like since y squared never merge, it should be lesser than the z squared, I thought. Huh? No. The z squared, it was being split, right? This is, you see, this is 6 over 36. Then this is 3 over 36, right? So it's 3 over 36 here, right? If you add both of them up, isn't it 6 over 36 is the same? Because just now this one was split into half. Okay. So now this one here, is it the same? Okay, actually, you can just write down this one. So the question now is it the same? So you just break down variance z is equals to expectation of z square minus expectation of z square. Okay. Then variance y is expectation of y square equals minus of expectation of y square, like that. This is one of the way. If you do not want to use this method, you can use other method. You just calculate it brute force. So variance z, okay, we know that ez square is equals to ey square. No question asked. Okay, this is the same. But ez is not equals to ey. Okay. Expectation of z will be what? Expectation of z will be, you want to give a guess? What's expectation of z? Expectation of z is equals to 0. Confirm 0, 1. Why? Because it's centered about 0. Right? It's the negative 1 would nullify each other on the other end, and negative 2 nullify negative 2, and so on. So easy confirm is 0, 1. So hence, variance z is not equals to variance y. This is one way you can write it out. Okay, so what I did was I just say variance z is this formula, variance y is this formula. So although these two are the same value, we know that z squared equals to y squared, but ez not equals to ey since yeah. So part 2. Any question? Ask now. Please ask. Keep asking. Okay. So